Okay, this is page 22 of the scheduling notes. We've got one page to go after this. This is section 6.4, and it is preemptive EDF, or earliest deadline first scheduling. And that's section 7441 in the text. And we have dynamic priorities, which means that they are determined at runtime, as opposed to fixed priority preemptive, where, as the name indicates, the priorities do not change. And the priority is inversely proportional to the absolute deadline, or like the current deadline for the current instance of a task minus the actual time. So what this really means is the closeness of the deadline. So the closer it gets to the deadline, the higher its priority. So the scheduler runs the task with the closest deadline. And it's as simple as that. Now this is preemptive EDF, so that means if a task with closer deadline is released, it preempts the running task. So the task has a closer deadline than the current running task, which had the highest priority until the new one got released. So with fixed priority preemptive, the upper bound on the processor utilization that can be achieved, it varies from about 70% and higher. With EDF, it is an optimal scheduling algorithm. If a task set can be scheduled by any scheduling algorithm, it can be scheduled by EDF, or preemptive EDF. One thing to note here is that there is no time slice. So the current task that is running will continue to run until it finishes execution or it gets preempted by a higher priority task. So you don't have this constant check to see who should be running. So the scheduler only runs if a new task is released or the current running task ends its current invocation. So this saves on scheduling overhead. Now, as for the schedulability tests, if we assuming that the deadline for the task is equal to the period, it is simply whether the processor utilization is less than or equal to 1. That's the schedulability test, so very simple. The schedulability test, assuming DI, well, okay, let's just say it this way. Not assuming DI equals TI is really hard. It's quite time consuming, and a lot of work has been put into how to calculate that in with low runtime complexity, but it's a lot more complex than rate monotonic, for example, which is one of the reasons that EDF hasn't taken over the real-time scheduling world, even though it is the optimal algorithm. And I actually did my PhD covered a bunch of EDF scheduling theory and stuff like that. So I'm quite attached to it, but unfortunately it's not used much in the real world. Let's look at an example just to show you how this works. So say we've got two tasks, and the first task, task 1, has a period of 4 and worst case execution time of 2, and task 2 has a period of 10, worst case execution time of 3. So we can calculate the processor utilization. It's going to be 2 over 4 plus 3 over 10, so 0.5 plus 0.3 equals 0.8, and that is less than or equal to 1. So this task set is schedulable by earliest deadline first preemptive scheduling, assuming that the deadline is equal to the period, which is what our assumption is. Okay, so the least common multiple of 4 and 10 is, well, the prime factors of 4 are 2 squared, and the prime factors of 10 are 2 and 5, so 2 squared times 5 is 20. So let's draw our timeline, and I will do 10 segments, and each one will be 2 time units. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so task 1 and task 2 will be released time 0, and then task 1 is going to be released every 4 time units, so 2, 4, 12, 16, 20. Task 2 is released at time 0, 10, and 20. So let's look at what happens at time 0 to start. So task 1 has the earlier deadline. You can see by looking at the green arrows there. So it's going to run for 2 time units. And then task 2 is the only one left running, and its deadline is at time 10. So it's going to run until time 4, at which point task 1 is released again. Its deadline is earlier, 8, than task 2, so task 2 gets preempted here. I should have done a dotted line there. So task 1 will run for 2 time units, and when that's done, then task 2 can finish its remaining 1 time unit of execution at time 8. Task 1 runs for 2 time units at time 10. Task 2 is released again, so it runs for 2 time units. So there's that dotted line just to show it's being preempted by task 1, which has a closer deadline. And then it resumes execution at time 14 for 1 time unit. We have an idle period here, and we had an idle period from time 7 to 8 that I didn't show as well. At time 16, task 1 runs for 2 time units, and and then we have an idle period from time 18 to time 20. So that's an example of preemptive EDF scheduling. And we should be able to count up the idle periods. So we've got 1, 2, 3, 4 divided by 20 is 0.2. So the percentage of idle time plus the processor utilization adds up to 100%.